Hello. In the previous video, I introduced the complement, which which is an operation on event, and we also learned what uh, like how the probability can be calculated if you take the complement and if you know the original event's probability. And in this video, I'm going to show you two more operations which are very commonly used and you already know them. So it's very similar to the set theory in mathematics. We are borrowing the same notation, and the main point of this uh, theory is to connect those set operations to probability calculation. So the second operation we consider is the union. So think about this event. You are interested in the event of female or having a health insurance. So you are interested in or, connect two events by or, which means at least one of them happens. So you have two events and you are combining these two events by defining the new events as like this, right? And we call this the union of F and H. And in mathematics, we denote it as F U H. Usually, this is called F cup H because later we will learn why it is called cup. So F union H or F cup H are how we read it. And in this case, when you connect the event by or, any outcome that any individual who is female satisfy this condition, and anyone who is covered by an insurance is also included in this event. So female covers these two outcomes and covered health insurance covers these two outcomes. So in the end, three outcomes are included in the event. So that's the probability. You calculate the probability from these three numbers, right? So what is the probability? Do the math. Then answer is 80.11%, right? And whenever you learn the union, it also comes with its counterpart, interaction. So interaction is a combination of two events connected by AND. Previously, we learned we connect two events by OR, but now it is AND. So it defines female who have health insurance. So it has to satisfy two conditions at the same time. Has to be female and has to have a health insurance. And statistically speaking, it means both F and H happen together, right? Previously, you just require at least one happens, but now you are requiring two, both of them happen. Then this new event generated from the two original events is called the interaction of F and H, and denoted as F cap H. We call this F cap. So previously we called U as cup, but now it is cap. So that's convention, and or you may just call this F intersection H. Doesn't matter. And in this case, the intersection is only this one. There is only one outcome who satisfy both conditions. For example, the first 1 by 1, 1 outcome is not covered, so H is not satisfied. And here, 29.95% people do not satisfy the condition F. So there is only one among four outcomes that satisfies the both conditions. That is intersection. So its probability is even simpler. What is the probability of the intersection? Because intersection has only one outcome, its probability is just the probability of the intersection. So that's how we define union and intersection. And second, the fundamental rule of probability is to sum all the probabilities for the outcomes included in that event. This is the main point of this chapter. Now let's think about more complicated event. So we learned three operations, and using those three operations, you can make almost any kind of complicated event. And if you understand the fundamental rule, the principle, then calculating the probability is not that difficult. Try this. Pause the video and see how you can calculate this probability. Okay, so if you have not finished your work, pause the video now. I'm going to explain. So let's think about the set, the events. First, event F. Event F includes these two outcomes. Event H includes these two outcomes. So then event H includes these two. So the other two outcomes are H complement. H complement includes these two outcomes. And then, so remember, H complement is this, and female is this. So female includes these two. H complement includes these two. And then their intersection, F intersection H complement, is the overlap. There is only one outcome that overlaps in F and H complement. The answer is 13.880%. So it's a little bit tricky, but as I said, following the principle, there is nothing difficult as long as you have the full information. Okay, and then from these observations, we extract formula. Now, so we would like to express the probability of those new events using the probabilities of the original events, like this. So the probability of union can be written as the probability of single outcomes, sum of the probabilities of the original events. But the problem here is you have to subtract their intersection, because when you sum those two, you are adding some outcome twice, some outcomes probability twice. So you have to cancel that out by subtracting the intersection. So the intersection is the overlapped area. So they are counted twice by summing these two. When you sum those two probabilities, so you are subtracting those two. That's the main idea, right? But I'm not recommend you to memorize this rule. The fundamental rule is this. I rather recommend this, but it does not harm if you understand and memorize this. Understand the intuition why we get this. And we, from the previous formula was a general formula, but some textbooks call this as the addition rule. So in this is a special case. When the probability of the union equals the sum of the probabilities. When is it true? Simply when the additional term is 0. If the subtraction is 0, then it becomes pretty simple, and that happens when the intersection probability is 0. So that means two events do not overlap. Two events do not happen at the same time. And statistically, we call this mutually exclusive. We call two events are mutually exclusive if they don't have any intersection. Intersection has 0 probability. Then you can write it this way. But I don't think it's that useful because it's hard to have this kind of mutually exclusive events. And in our example, the F and H are not mutually exclusive because the intersection has a positive probability. Already we learned the probability is not 0, so they are not mutually exclusive. For them to be mutually exclusive, this probability must be 0. Otherwise, they are not mutually exclusive. Okay, this is end of the one part of this chapter. And the next video, I will consider another term. We are going to learn joint distribution and marginal distribution. Okay, see you later.